order to explain the peculiar behavior of objects in the outer reaches of spiral galaxies, let us treat our own solar system as a tiny galaxy model, where the Sun is the nucleus of the galaxy and the planets represent stars in the spiral arms. The innermost planets, Mercury and Venus, move much quicker around the Sun than more distant planets, such as Saturn or Neptune. The law of gravity dictates that the rate at which a body orbits the center body, in this case, the Sun, is directly related to its distance from said center body. Specifically, the farther away a planet is from the Sun, the slower it moves in its orbit. We know this to be true. In fact, scientists know to extreme precision how long it takes for each planet in the solar system to revolve around the Sun. The same dynamic was expected for galaxies. In the spiral arms, far from the massive nucleus at the center, stars and gas should move slower the farther out they are. However, what astronomers actually discovered was that this was not the case. In fact, astronomers observed countless galaxies and found that the orbital speeds of objects in the outer regions were nearly the same no matter how far away from the center they were. How can this be true? Is our fundamental understanding of gravity flawed? While there is not currently a definitive answer to this problem, scientists prefer the idea of dark matter over searching for a refined theory of gravity, at least for now. So, how does dark matter fit into this picture? As was implied earlier, the law of gravity states that all bodies that have mass attract other bodies with mass, and that the magnitude of that attraction depends on how massive the bodies are. If there was some sort of gravitational glue forcing the stars and gas in the spiral arms to move together, that would explain their strange behavior. This is exactly what scientists think dark matter is. Undetectable particles that have a gravitational pull on the objects around them. And the math checks out. By analyzing computer models, scientists have shown that the existence of high concentrations of dark matter in the outer regions of spiral galaxies ensures that the predicted motion of objects in those regions matches what is actually observed. The first question you might ask is, if it is not visible or measurable, then how do we know it is there or how it functions? The most direct evidence of dark matter is in spiral galaxies, specifically in the outer regions of their spiral arms. As far back as the early 20th century, astronomers noticed that the stars and gas in these outer regions did not conform to the known laws of gravity and orbital motion. In 1933, Fritz Zwicky, a Swiss-American astronomer, was the first scientist to propose that there was some sort of non-visible matter responsible for the anomalies found in spiral galaxies. He called this hypothetical matter Dunkelmaterie, which literally means dark matter, because he could not see it. Since then, dark matter has proven to be as mysterious as it was when Zwicky first thought of it. Could dark matter be powering a hidden class of stars? Meet the dark dwarfs. Sparkles. A groundbreaking new theory proposes that dark matter, the invisible glue of the cosmos, might do more than just hold galaxies together. It could ignite a whole new class of stellar objects, dark dwarfs. These aren't your ordinary stars. Unlike our Sun, which shines through nuclear fusion, dark dwarfs might be powered by something far more exotic, the annihilation of WIMPs, weakly interacting massive particles, a leading dark matter candidate. How would it work? In the dense heart of our galaxy, brown dwarfs, failed stars too small to sustain fusion, might trap enough dark matter to spark a different kind of energy source. If those wimps collide and annihilate inside the brown dwarf's core, they could release heat, making the object glow brighter and hotter than it should. The smoking gun. Lithium, 7. Regular stars burn through lithium fast. But if a red dwarf-looking star still contains lithium, 7, it's a clue it hasn't undergone fusion, making it a prime suspect for being a dark dwarf. Though still theoretical, the idea opens a radical new window into the dark universe. These dark dwarfs might be scattered across the Milky Way, especially near its center, waiting to be found. If real, they'd be glowing testaments to one of the universe's most mysterious forces.